All right, so now we're into the final video of our translation here. And up till this point, we have the ability where we have a star kind of going up through the screen and recycling itself back down to the bottom. Our spaceship has the ability to move around. And you see that little, see that happens when you try and interact with your game and you haven't clicked on the screen yet. There we go. So I can move my spaceship all around. What we're going to do now is we're going to add another element of translation. We're going to create bullets that kind of fly across the screen. That's right, bullets, more than one. So how many? Well, that's going to be part of the whole problem here. So looking up at the top here, we have a whole bunch of, adjust my chair. We have a whole bunch of different data that represents different objects in our game, such as the player, such as the star and whatnot. We even have a sprite sheet for our bullet already. But the thing is, I want more than one bullet. So I can't just have a single sprite sheet for that. So instead of having a single sprite sheet, I'm going to have an array of sprite sheets. So I'm going to call this bullet images. So it's because there's more than one. And how big is this going to be? Equals new sprite sheet. What's going to go inside those square brackets? Well, I'm going to create a new constant for that. Final int max bullets. And what max bullets is, it's going to be the maximum number of bullets that are visible on the screen at once. So the maximum number of bullets you can have shooting at one time. So if it's 3, that means you're going to have to wait for one of them to be destroyed before you can shoot another bullet. And that's the idea. So when we think about our bullets and our images, we're going to consider them either active or inactive. But how do we track that? What does that actually mean? Well, there's already some built-in concepts inside of our sprite sheet object that we can use, such as the visibility property. So if we use that visibility, so whenever it's visible, we can consider it active. Whenever it's not visible, we'll consider it inactive. So whenever we want to shoot a bullet, we're going to have to activate it by changing it to visible. Whenever we want to deactivate a bullet, that means we have to change it invisible. Now the question is, when do we deactivate the bullet? We'll come back to that in a little bit. So let's finish setting up our bullet first of all, or our bullets. So we have our array here of sprite sheets. We're going to go down into our load content. We've already loaded the bullet image. Okay. Now we've only loaded one of them though. We need all of them. So I'm going to take this out for a second, Control X, and I'm going to go a little bit below this, and we're going to create a for loop. For int I is equal to 0. Now remember, whenever we want to loop through an array, our I value, our counter variable, represents all the possible indexes of our array. So since the first index is 0, we're going to have I starts at 0. We want to keep looping as long as I is less than our bullet images array dot length. So we're going to loop through every single element of the bullet images array, I++. Now inside of here, we're going to define them. So instead of bullet image, we're defining every bullet, so the current bullet image. So we're saying the current image. So the first time through the loop, this is a 0, and then a 1, and then 2, and so on and so forth. So every single one of these, I'm defining them by loading the image and setting up the animation. So this animation is one row. It has 6 columns. We're going to start animating on the first frame. The whole animation is 6 frames long. And we are going to delay the animation by 5 updates. So that means that we're slowing it down because it's a really short animation. It's only 6 frames, right? So if our game runs at 60 frames per second, that's a tenth of a second. Tenth of a second? Yes, a tenth of a second. So obviously that's really quick. We'll barely even see it. So what I'm doing is I'm slowing it down. So now it's quite a bit longer. It's going to feel like it's much longer in length. 6 times 5, so 30 frames, which means a half a second. It's quite a bit difference. Okay, so now what? Now what we're going to do is we need to set up the destination rectangles just like we do any other image. You notice that we haven't done the destination rectangle for the bullet images yet. We're going to do it inside this loop because we need to do it for every single one of them. So bullet images at I, so the current bullet, dot destrec is going to be equal to a new rectangle. Now remember, our new rectangle has to be a position and a dimension. So what position? You know what? It doesn't matter. And the reason why it doesn't matter is because we're not going to be drawing it if it's not active. And it's going to start out as inactive. So we can put it anywhere we want. I'm just going to put it at 0, 0. Now you might be thinking, but what about collisions and things like that, Mr. Lane? There's more than just drawing to these things. Yeah, there is. But the thing is, we're going to use that active idea for everything. So it's not going to move unless it's active. It's not going to collide unless it's active. It's not going to be drawn unless it's active. Everything is going to be dependent on that. So the computer doesn't do as much work. So we have an arbitrary position of 0, 0, and now we need a width and a height. So we can just get that from the image. So our bullet images, our bullet images at I dot get frame width 0, get frame width, and then the same thing for height. Now, if we look at this and we say, oh, that bullet is too small, then we can change this later on just by multiplying this by something, because it is a pretty small animation, so we'll see. But we are shooting it from our tiny little spaceship, so maybe it's fine. So we've set up the destination rectangle. But according to this system, like everything by default, all sprite sheets by default start as visible. So we have to set it to invisible as well. So bullet images at I dot set visibility. Oops. And we're going to set it to false. So it is not visible, which means it's currently inactive. So we've loaded all of our images, we've set up the rectangles, and we've set them to inactive. So now we have an array of inactive bullets. We can go draw them. Now remember, I said we're going to be using this loop to loop through all of our bullets a lot, so much so that I'm going to copy this. And we are just going to paste it down in our draw command. So let's go way down into our draw game. Here's our draw gameplay. And I'm going to draw our bullets inside of here. Now here's the thing. We can just say draw.sprite gfx and then the current bullet images at I. Now that will draw all of our bullets, but the problem is it will draw all of our bullets whether they're visible or not. So let's demonstrate this by running the program. What did I break? Oh, I forgot to set the size of our bullet images. I forgot to use our constant. Max bullets, right there. So let's try again. We're gonna go back down to that draw command. We're gonna run it. Now remember, all the bullets are located at 0, 0. What did I break now? Bullet images at I dot set visibility to false. What did I change? Let's go take a look. So it looks like I just called the wrong command. So it's not set visibility, it's set visible. My bad. There we go. Set visible. Is that right? Visible? Did I spell that right? I did not. It's visible. Spelling is not my strong suit. Visible? I don't know. Let's see. Let's open it up and verify. Visible. We'll just copy it. Just to make sure. Is that visible? There's no... There we go. That looks right. Spelling. Not for Mr. Lane and his computer science brain. So there we go. Where are our bullets? Why are we not seeing our bullets? Where are our bullets? Our bullets should be drawn at the top left-hand corner, but they're not because we've set them to false. If we just set this to true now, just to show it, and we run it, there they are. Now it's not animating or anything like that. It's just kind of sitting there. That's fine. If we want to animate it, what do we need to do? We need to say start animation. And we don't want to start animating it though, because we don't want to animate it until the player actually shoots the bullet. So that's going to be part of the activation code. So we're going to turn this back off. All right. So when do we want to start shooting our bullets? Well, we want to start shooting our bullets whenever the user clicks some kind of button, some kind of shoot button. In this case, most games use the space key to trigger a shot. So we're in our update gameplay. So there's our movement code. So for next our input, we're going to check that space key. So if input dot is key down key event dot spacebar. So if the user clicks the spacebar, we are going to trigger a shot. But which bullet gets shot? We have an array of bullets. What if we've shot 3 and we want to shoot a 4th? So is it just going to go to the next index? Maybe. Maybe. What if we've shot 3? The first one is destroyed and deactivated before we shoot the 4th. Should it go to the 4th index or should it go back to that first index? And the truth is, it should always go to the first index that is available, the first bullet that's not currently active. So how do we find that? Well, what we're going to do is we're going to create a new subprogram. We're going to create a new method down at the bottom of our program, down here. And we're going to create it. We're going to say private int find inactive object. And what we're going to take into this is an array of sprite sheets. I'll just call this objects. And the reason why I'm calling it the generic term objects is that in most games, you have a lot of things that are either active or inactive. And for example, you might have, maybe you're making an endless runner and you only have like 5 obstacles to work with. You don't want to create an array of 1,000,000 obstacles while the player plays their endless runner. You only want to create a small collection of them because it takes up memory. And then as they get off the screen, they get recycled and redrawn again on the other side of the screen. So this would be something like this. You'd find the first one that's inactive and then reactivate it. So that's the idea here, is behind find inactive object. We're looking for the first object inside of our array that is not active, which means it's not visible. So it should just be a for loop. So for int I is equal to 0, such that I is less than our objects dot length, same loop that we've been doing the whole time, at I++. Now a simple if statement that just says if, where is it? If objects at I dot get visibility. I wonder if that's the right one. I wonder if that's get visible too. Let's go find out just before I make too much of a mistake here. Let's see. So there's our set visible. Where's our get visible? Get angle, start frame. Where are you? There it is, get visible. See, I would have got it wrong again. My own code and I just don't remember these things. Okay, so if it is currently visible, we don't actually want if it's visible. We want if it's not visible because we're trying to find the first inactive object because our goal is to shoot one. So we're going to say if it's false. So if it's not visible, this is the one we're going to be activating. So all we have to do is return I, because we're returning the index of the first one that's visible. But what if they're all shot? What if every single one of them is on the screen right now? What should we return? We're going to return an impossible index. So the rest of our code knows, hey, this is not a valid object. Don't use that. So normally we would return something like -1 because -1 is an impossible index. But -1 is a magic number. So what we're going to do is we're going to create a constant for this. We'll call this constant no object, meaning we could not find an object. So let's go up to our variable section up top, and we're going to create a constant for that. So final int no object, which is equal to -1. So now we can use that anywhere else in our code. So down at the bottom here, this thing will basically say, look for the first inactive object. If we find one, return its index. If we don't find one, return a -1. So we're going to use that in the rest of our logic up here. So we need to call this function, and we're going to pass into it our array of bullet images. Now again, you could pass in any array of sprite sheets, and it will find you the first inactive one. Now it's going to return us an index, so we need to store that. So I'm going to create a variable up here, int bullet index, and I don't know if there is going to be one, so I'm going to start that one at a value of no object. So bullet index is going to be equal to find inactive object. And maybe it finds one, maybe it doesn't. We don't know. And that's what we're going to check. So if it did find one, so if bullet index is not equal to no object, which means it found one, it's time to activate a bullet. Which bullet? The bullet that's located at bullet index, whichever one that is, who knows? Doesn't really matter as long as it's inactive. So what are all the things that we need to do to set it active? First thing, we need to set its visibility property. So bullet images at bullet IDX. So that's the one we found. We're going to say set visible to true. So now it's officially active, but that's only part of it because there's a lot to this bullet. First of all, it also has an animation, so we can start its animation. So I'm going to grab this so I don't have to keep typing this. We're going to say .start animation. Okay, start animation. All right, so now it's animating. What else? So we have it at the top of the screen right now, and it's animating, and it's visible, but it's not actually doing anything. And it's also in a weird spot. If we were trying to shoot it from our spaceship, it should probably be located near our spaceship. So we need to move its position. So we're going to move it to, since we're shooting across the screen to the right, we're going to move it to the right side of the spaceship. So we're going to use the spaceship's current location as kind of like a relative point. So we're going to say bullet images at i.set position. And what is its new position? So we just have to set its X and Y. So its position is going to be the current position of the spaceship, but shifted over a little bit. So we want the right side of the spaceship. Remember, the position of the spaceship is the top left-hand corner. So in order to get the right side of that, I have to take that X value and I have to add on the width of the spaceship. Okay, so let's do that. So we have our, what do we call our spaceship? Player? There it is, player image dot get position. I think it's get pos. Player image dot get pos dot x, and we are going to add to that the width of our player image. So player image dot get width, or get frame width, sorry. Okay, so that is going to give us the right side of the spaceship, but now we need it down a little bit. So we need to get the Y value of the player image. Give me my mouse, please. My mouse is acting up on me. So we want to get the right side of the, or sorry, the top of the image dot Y, and we want to add on something. Where do we want to put it? Maybe half the height down, half the height of the spaceship down, so it's shooting directly from the center, maybe? Sure, we can do that. So let's try that. So player image dot get frame height divided by 2. Okay, now this is there's a lot going on here, so let's kind of bring this down a line so we can see everything together. So our X value is the left side of the spaceship plus its width. Our Y value is the top of the spaceship plus half the top of the ship's height, spelled correctly preferably. So right now we've relocated our bullet to right in front of the spaceship, and it should be animating. Well, let's find out. See if I broke anything. Of course I did. Key event dot, console VK space. This is what happens when I'm programming in multiple languages simultaneously here today. So there's our space. What else did we break there? Our get position. Again, a factor of me working in multiple game engines in a single day, I don't need get position. I just need the dest rec. I don't know what's going on with me today. So we have dest rec, and then we have dest rec down here as well. Okay, so we have our player image dot dest rec dot x dot dest rec dot y, and we're adding in the frame width and frame height. So let's try this again. And we're down to the last one, so that's set position. Again, we don't need to set position, we just need to set the dest rec. We need to set the dest rec x and dest rec dot y. So dot x is equal to that. And then we'll just copy and paste this. And we're going to set the y equal to this piece. Get rid of these and put our semicolons where they belong. There we go. So let's look at this again. So we're setting the rectangle location of our bullet image, and we're just moving its overall location. So let's see if this runs now. Okay, so we're going to shoot a bullet, and there it is. It's right in front of us, and it's animating. It looks a little low, and I think that's because we set it to the middle of the spaceship, but that's the top left-hand corner of the bullet. So we could probably adjust it by subtracting half the bullet height as well from our Y value. So we could take away this, and we could say subtract our bullet images at bullet index dot get frame height divided by 2. And that will actually center both horizontally and vertically. Well, I guess just vertically, no, not horizontally. And there's our bullet. Now that makes a little bit more sense, and it's animating. It's not moving though. We've activated it, but we haven't done anything with it. So now this is the next step. So this is activating. So shoot a bullet on the space key if one is available. Okay, so if we only have 1 or 2 bullets available, we may not have a bullet to shoot. So this is getting our input. The next step is to actually move the bullet. So look, this next section where we're moving the player, here's where we're moving the star. So let's move the bullets right here. So now we have to loop through all of our bullets again. For int I is equal to 0, such that I is less than our bullet images, dot length. And we have to say I plus plus. And then what we're going to do is we are going to move every single bullet. We're going to just basically the same stuff that we did here, but with the bullet. Now here's the thing. We don't want to move every bullet. We only want to move the bullets that have actually been shot. And how do I know that they've been shot? They're active. They're visible. So we have an if statement around this that says, hey, if bullet images at I dot get visible. If it is visible, then we are going to move it. So again, we have to do the same thing for all of these guys, the same thing that we have here, which means we need data. We need variables for all that stuff. We need a variable for the speed of the bullet. We need variable for the true positions of the bullets. We don't need the DesRec because we already have that. It's part of the images. So we are going to have to go create vector2fs for all of the positions and for the speeds. We don't actually need this direction, though, or anything fancy. This is actually going to move much more similarly to the star because our bullets are always moving to the right. So we're going to look at something more like this. We're going to have our position, and then we're going to add to that some set value for a bullet speed. So we're not going to have some ugly speeds for like vector2f for our speeds. So let's go create our bullet speed variable. Remember, this is going to be much more similar to the star speed stuff. Now, the star is moving pretty fast. We'll see if the bullet needs to move just as fast. So float, yeah, that's fine. Bullet speed. And let's say it equal to, I don't know, 2F. So it means it moves 2 pixels per update. Okay. Next thing we need to do is we need to create a vector2f for every single bullet because each one is potentially in a different location. Not potentially, it definitely will be in a different location. So we need to create an array of vector2fs. So vector2f bullet positions. Bullet pos? Bullet pos? We'll just say bullets position. I don't know. That's a tough one to say the plural of. So bullets pos equals to a new vector2f. How big is this array? It's the same size as our bullet array, so max bullets. Because we're going to have one vector2f for each bullet in the system. Okay, we don't know what their current speeds are. In fact, right now they don't even have a speed set up. So just like we set up all of our bullets here, we're going to set up our positions for each one too. So our bullet, let's grab this. This guy is going to get, it's going to equals a new vector2f. And we have to set its speed, or sorry, its position. And it doesn't matter what its position is because it's not actually moving. So we could actually set it to the same position as our bullet images at DesRec. And just to be clear, we will actually do that. So we'll grab the current bullet image, DesRec, .x, and then we'll do the same thing for the y. So it's located at the exact same spot that we spawned our bullets, just to be safe. Okay, just in case we decide to move where that location is. This is dependent, the bullet position is dependent on the actual location. All right, so that's the value that's going to be updated by the bullet speed every single update. There's the bullet speed. So like I said, it's going to move just like the star does. We're going to go down to the code for the star. So the star says update the position first. Okay, we're going to update the position. So the position is that bullets. Nope, wrong one. Bullets position at I dot x, because we're moving its x direction. It's going to be equal to its current position. Now, of course, most of you know that we could just use plus equals to shorten our code down, but that's okay. I'm trying to be clear to everybody. So bullet speed And there we go. So that we're adding the bullet speed to the current X position. We're not going to change the Y value because our bullet's not moving vertically. It's only moving horizontally. Once we've done that, we just need to update its drawn position. We've updated its true position. Now we're going to update its drawn position. So that is the actual destrec. So bullet images at I dot destrec dot X, we only need to change its X value, is going to be equal to the casting of that value. So bullet's position at I dot X. There we go. So that will officially move our bullet across the screen. Hopefully. Let's find out. All right, let's shoot. There goes our bullet. Okay, so did anybody see that it actually started to the left of our ship? Okay, so why? Why did this actually happen? Well, it's because of the way that we set this up. We changed its position. Where is it? So when we first defined it, so when we activated the bullet, we set the bullet's destrec. But the bullet position itself hasn't changed. The true position. We set the draw position, but we didn't set the true position. So we also need to set the true position as well. So bullet at the same index dot X is going to be equal to the destrec dot X. And we do the same thing for Y. So now it will actually appear, it'll start at the same location that the draw location does. So now it'll actually start shooting from the front of the ship. Shoot, there we go. That's a lot better. It's moving pretty slow. And it's just going along, doop-a-doop-a-doop-a-doop. I should be able to shoot another one. And why am I only able to shoot 2? So that is the better question. How many did we set our max bullets to? So we set our max bullets to 5. So the question is, why can we not shoot another one? Why is it only shooting 1 at a time? Is it possible that we're actually getting more than 1 bullet at a time for every key press? Well, yeah, it is. Because remember, it's just checking to see if that space key is down. If that space key is down, it's going to trigger that shot. Well, that space key is going to be down for more than 1 update because we can't possibly hit the space key for 1/60th of a second. So instead of is key down, this is a good time to use is key released. So it only does it when we actually let go. So let's try again. Assuming I spelt that right. So shoot, 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 shoot. So we can have 5 bullets open at once. But I can't shoot anymore because nothing's killing the bullets. Something's got to kill the bullets. Something's got to deactivate them. Okay, so let's go deactivate them. So what deactivates them? Down in collision detection. So in collision detection, this section, which is usually, as we said, near the end of our update, we need to basically say when it hits something. In this case, we're just going to say when it gets off the screen, deactivate it. That's all we got to do. So we have the exact same for loop that we have here. For every bullet that's currently active, if it gets off the screen, so we could do it as a compound statement here, or we could do it as a separate nested statement. So if it's currently off the screen, that means its X value is greater than the width of the screen. Okay, greater than or equal to, but greater than is fine. So if it's X value, so if bullet images at I dot X is currently greater than or equal to the window width. Now, why is it just the X? It's because we're not looking for the right side of the bullet. We're looking for the left side of the bullet. And the X position is the top left-hand corner, right? So if it's greater than the window width, that means it's left the screen. So we want to deactivate the bullet. Man, we had to do a ton of work to activate the bullet. We had to set it visible, we had to start the animation, we had to set its draw position, and we had to set its true position. That's a lot of work. But what do we have to do to deactivate it? We only have to do these 2 things in reverse. We don't care about its position when it's not active because it's not being drawn, it's not being collided, it's not being moved with. We only care about these 2 to deactivate it. So we're going to go down. We're just going to paste these in here. So when we want to deactivate, we're going to set that to false. Remember, the whole check down here to find inactive is only looking at visibility. And we're going to say stop animation because we don't want to waste the effort of animating if it's not actually doing anything. All right, so now we should be able to recycle the bullets. Whenever they leave the screen, what did I change here? .desdirect.x. There we go. So whenever it leaves the screen, we're basically just turning it off. So let's shoot. We'll shoot the first one. Just make sure that it leaves and disappears. So it should be gone now. We got an error. Index -1 out of bounds for length 5. Now, why did we get that error? So let's go find out. So looking at this, the reason why we got this error, it's a copy-paste error. I'm using bullet index. Bullet index doesn't really exist here. Well, it does because we created it elsewhere, but it doesn't have the value we expect. We should be using I. This is the dangers of copy-pasting. So this is why we test. So we run it again. All right, let's shoot. Let's get all 5 shots going. And we shouldn't be able to shoot again until until one of them leaves. And now I can shoot again. Now you might be saying, wow, Mr. Lane, the user can spam those keys. Maybe. You could put other things in there, such as like timers and stuff like that, to say, hey, you can only shoot when the timer is expired. So for example, maybe you have like a ½ second timer or a ¼ second timer that says when this timer is expired and you hit the space key, then you can shoot. There's a lot of different options you can do to approach that situation. Now, we could also play with the idea of the max bullets. Maybe you want the user to be able to spam that thing. So if that's the case, all we have to do, all this work that we did, we only have to change one value to increase the number of bullets, max bullets. Let's say we change it to 50. And all of a sudden, with that one change, we've completely altered this. So we don't have to change any logic for the whole program because we designed it using everything relative values. Let's get... So we can spam as much as we want. And again, it's just recycling. As soon as they leave the screen, they come back. Now, these bullets actually move with me. Because remember, they shoot from wherever I am, wherever the player is. And they all have their own location. They all are moving by a specific speed. And that's what I call spam. Okay. So what you can see here is that we've applied translation to a number of things. We've applied translation when we control it, such as when we're moving the player up and down, left and right. We've applied translation when it's an automatic thing the whole time, like the star. Or we've applied translation when we trigger an event and we say, keep going until something happens. In this case, we don't need a while loop or anything like that to do that because we're already in the game loop. Just every time through the update, we just have to say, has this thing happened yet? In this case, it's, has it reached the edge of the screen? If it has, you're done. Bob's your uncle. Okay, we're going to stop there for the day, and we'll move on to scrolling screens in the next lesson, and hopefully we're getting a little bit further. So good luck and have fun.